Hello, this is Mr. Kenyanola, and I'm going to help you find the sine and cosine values in a unit circle. So here's a unit circle, and before we start, let's do some quick review. Sine is so. Sine is opposite over hypotenuse, and cosine is ca. Cosine is adjacent over hypotenuse, so the adjacent side over the hypotenuse. And a unit circle, remember it's called a unit circle because what? The radius is 1 unit. So we're going to look at a few triangles and try to figure out a pattern so we can figure out the sine and cosine of values pretty easily. So I have 3 triangles here. There's a green, there's a blue, and there's a red. Let's just stare at this first one, this green triangle. Okay, so this triangle right here is a 30, 60, 90 triangle. And it's 30 degrees because it rotates there. And if the question asks, or if you're just wondering what is the sine of 30, well, remember sine is the opposite side, and this side is 1/2. We know it's 1/2 because this is vertical, and that's the distance from for this y value. So it's 1/2 over the radius, or over the hypotenuse. And this hypotenuse we know is 1. So we can write sine of 30 degrees is equal to 1/2. Is the opposite over the hypotenuse, which is 1, which is equal to just 1/2. Okay, and let's find the cosine of 30. And cosine of 30 is the adjacent side. So it's this length right here. And we know the length is radical 3 over 2 because that's the x value, or the horizontal distance, over 1. So the cosine of 30 is radical 3 over 2 over 1, which is just radical 3 over 2. So that's the cosine. Okay, let's look at some other values. So let's look at this blue triangle right here. And this blue triangle is a 45, 45, 90 triangle. Okay, and if we wanted to figure out, so let me put that 45 right here. And if we wanted to figure out what the sine of 45 is, okay, it's the opposite. So which is the length of this side, which is radical 2 over 2. Okay, over 1, which is this right here, because that's the hypotenuse. So the sine of 45 is really just radical 2 over 2 because the opposite's over the hypotenuse. Cosine of 45 would be the adjacent, would be this length right here over the hypotenuse, which is this, and which is the cosine of 45, and the length of this adjacent side is really the x value, so it's radical 2 over 2. Let's do one more just for good measure, and you may start to see a pattern by now. Hopefully you do. So let's look at this red triangle right here. And this is a 60-degree angle right here. And if we wanted to find the sine of 60 degrees, it's the opposite. What's the distance? What's the length of this line right here? Well, it's vertical. And so that's represented by the y value. So the sine of 60 is radical 3 over 2. And the cosine of 60 is the adjacent, which is this side, which is represented by the x value, over the hypotenuse, which is 1 again. So cosine of 60 is just 1/2. So do you guys see a pattern there? I hope you do. I do. The pattern is, what's sine really represented by? Well, it's opposites over the hypotenuse. Hypotenuse is always 1. So really the sine is just the y value. Look at here, the sine of 30 is just this y value. The sine of 45 is just this value, radical 2 over 2. And the sine of 60 is radical 3 over 2, which is just the y value. Okay, so we can conclude that the sine is the the y coordinate. Okay, and let's see, cosine, as you may have guessed. So let's look at this cosine of 30 over here is radical 3 over 2. And let's look at that. And hey, that's the x value. The cosine of 45 is the x value, and the cosine of 60 is the x coordinate. So cosine is the x coordinate. So let's box this right here. So if I said sine, you'd say y coordinate. If I said cosine, you would say x coordinates. If I said x coordinates, you would say cosine. If you say y coordinates, you would say sine. So let's put that in your brains. So not too bad. So let's do some example problems. Just remember, sine is the y and cosine is the x coordinate. So let's look at this right here. So it says find the exact value of each trigonometric function. And so this is 300 degrees. It rotates 300 degrees, and it's the sine. What is the sine? It's the y coordinate. And let's just refer, if you haven't memorized the unit circle yet in your brains, you should. I highly recommend it. It's good for you. If not, let's just refer to it. 300 degrees. So we go 300 degrees right here, and sine of that is the y value negative radical 3 over 2. So your answer is negative radical 3 over 2. And let's look at this one, cosine of 240 degrees. Cosine, remember cosine is the x value. So let's go 240 degrees around, and that is the x value, which is negative 1/2. Yeah, that was pretty easy, huh? Let's do two more problems, two more examples. So we get in our brains that the sine is the y, cosine is the x. But this time, it's not in degrees. Look at it. It's in radians. Well, doesn't really change much, especially if we have the unit circle in hand. So the cosine of 5 pi over 6, that's in the second quadrant. Remember, cosine is the x value. So let's go rotate and find 5 pi over 6. And it's the cosine. So our answer is negative radical 3 over 2. So 5 pi over 6. And this one is sine of 7 pi over 4. It's in the fourth quadrant, and the sine is the y value. So let's find 7 pi over 4. 7 pi over 4, and we want the sine, and it's negative radical 2 over 2. So that's it. I would suggest putting this in your notebooks, make a power card out of it, make a flashcard out of it. And remember, the sine is the y, cosine is the x, because the sine is the opposite, and the opposite is the vertical, or the y value. And cosine is the x, because it's adjacent, which is the x value. And hypotenuse is always 1, so we don't really have to do any math. We just look at it. Sine is y, cosine is x, cosine is x, sine is y. That's it. Have a great day.